Assalamualaikum and good afternoon to sir. Today we would like to present you our final report for database system and information retrieval. This is our group member, which is me, Muhammad Shamizan Hairi bin Shahrizan, Abdul Rahman bin Basirun, Luqmanul Hakim bin Sadaruddin, Faiz Iqbal bin Muhammad Fattah. For project information, our objective is to design and create a database to support application system in an organization and are able to resolve problems in data management for the application system. About the database, in order to design a working prototype, we use some tools such as Violet UML and Microsoft SQL Server for implementation purpose. The food chain management system requires extensive knowledge regarding its branch information and location. The food chain management system also want to keep track of all their employee, branch, customer, food and service information as they use the system, and by designing and building appropriate database for the system, we will be able to handle and organize all the data properly. As for the problem need to be solved, tracking the data across the region in Malaysia can be quite a hurdle, and by implementing this database, management users are able to keep track of all the changes in a certain region at any given moment. As for the database objective, design a working database to help management user, staff, customer service, and food to be organized properly. As for the user that will be using this database include management user, staff, and customer. Database system environment will be using Microsoft SQL Server as for its database. I will pass to the next presenter.
Thank you, Mizan. Next, I will continue the presentation with to present our conceptual design. This is our conceptual entity relationship diagram for project. We can see we have a staff table, and the attribute is staff name, staff location, staff IC, and staff ID. And for the next table, we have order, and attributes is order ID and order ID. Next, product. Products, the attribute is food ID, food name, food price, and food description. For the for table, the attribute is branch ID, branch location, and next, receipt. The attribute is receipt ID. For the last table is customer. For the customer, we have the attribute is customer payment, customer pay method, and customer ID. And for a relation model for our conceptual diagram is branch attributes, branch ID, branch location. The primary key for branch is branch ID. Second, staff. The attribute is branch ID, staff ID, staff IC, staff name, and staff location. Foreign key for this table is branch ID. Primary key is staff ID. Alternate key is staff IC. Next, customer. For customer, the attribute is staff ID, customer ID, customer payment, customer pay method. Foreign key for customer table is staff ID, and primary key is customer ID. Next, order. For the order, attribute is customer ID, order date. For the customer table, the attribute is staff ID, customer payment, and customer pay method. Foreign key for this table is staff ID. Primary key is customer ID. For the order table, the attribute is customer ID or the ID or the date. Foreign key for this table is customer ID, primary key or the ID. Next, product. The attribute is order ID, food name, food price, and food description. Foreign key for this table is order ID, primary key is food ID, and the last one is receipt. The attribute for receipt is receipt ID, customer pay method. Primary key for this table is receipt ID, foreign key is customer pay method. I will pass this presentation for the next presenter.
Thank you, Faiz. I will continue for relational model or logical design. So for relational model, one branch, relational model diagram, ERD. One branch can have more than one staff. Staff also can receive more than one customer. And then the customer can make only one order. And then one order can have more than one product. And then the customer will receive only one receipt. For the second diagram, the UML notation have been updated using the relational model, so the user can navigate from database better. So for the branch, there is a branch ID and branch location. For the staff, branch ID and staff ID. And for product, order ID and food ID. And the order have customer ID and order ID. And for customer, I have staff ID and customer ID. And for the receipt, I have receipt ID. Next, I will explain about query design. This is the type query that we will do. So we will create a new table, and then we insert the data into the table, update the data from table, and lastly, we will delete the data from the table. I will pass to the next presenter.
Thank you, Lukman Hakim. So we're moving on to the implementation stage. So as you can see here, we can create table queries for all tables, such as the staff table, moving down to the branch table, right? Branch table, then we have customer table as well as order one table, and also finally with the receipt. So each table has its own queries that when inserted, they will come out a certain successful outcome. Okay, so we will then proceed with the alternation or alter any table. So from this part, we can alter any data from each table. So such as the receipt table. Okay, so we can alter any information, any data within that table, and the query will come out successful. Okay, then we also have the insert data into respective table. So first we can insert several separate data into each of the tables, such as the branch table here. We can insert or edit any data, and then we can insert into multiple other tables, including staff data, staff table, branch table, and also the staff. Okay, so customer table. Okay. Well, we're moving on to the order table. Okay, so final part. Then we have a food table. So let's finally the receipt table. Okay. So After the insert, we can update any data within the table. So the update procedure will be done as follows. So here, as you can see here, these are the examples of how we update table before and after we update the data. Okay, so after this example, you can see here, the final part will be the delete any data from each table. The addition of data we can see here before and after, how we delete it and how we manage to use the query to delete each data. So finally, moving on to the final presenter.
For the conclusion, we are able to manage the food chain in a more organized way and better efficiency due to database implementation. Tracking all the change are much easier compared to before, as the data influx is much more controlled. That's all from our group. Thank you.